Good evening, everyone. I hope I am audible to all of you.
Good evening.
My screen is visible to you.
Yes, sir. Yes, sir.
Okay,
Yes, sir.
fine. Thank you for joining me today. I'm excited to take you on a journey into the world of hydrogen vehicles. Today, I'm going to share my view on the topic of hydrogen vehicle driving towards sustainable future. Okay, so let's start with the current state of automobile industries. As we all know that our planet is facing unpredicted challenges due to the climate changes. We see that earthquake, tsunami, global warming due to the reason of CO2 emissions. And it's a mutual role, like when we are transportation is creating a huge CO2 emissions, while as a airway, transportations, buses, cars, you see lot of emissions due to the CO2. That's why we are moving towards the green technology, and that green technology is coming with the eco-friendly, less emissionable vehicles, or in the vehicle should be in the basis of hybrid vehicle. So it's a crucial part to explore the cleaner and more sustainable alternative in the transportation sector. This brings us the topic of hydrogen power vehicles. So basically, we are promoting the green technology and low emission vehicles. So we are talking about hydrogen vehicles. So what is hydrogen vehicle? A hydrogen vehicle is a core. It involves the uses of hydrogen gas to produce electricity and powering an electric motor. Basically, it's a similar to the electric vehicles, but somehow we are not giving a charging and discharging technique with the uses of infrastructure or from the onboard charging and offboard charging. We are basically providing energy store in the battery with the help of fuel cell. A fuel cell where the chemical reaction should be processed with the hydrogen and oxygen and generate electricity. It's like you can at the emitting, it can emit the water and the heat. Okay, so these technologies are game changer quest for the cleaner transportation. So we can say that hydrogen vehicles are eco-friendly in the technology, zero emissions and efficient power. So as I told that we are not emitting CO2, so it's a eco-friendly, zero emissions because we are emitting only the water vapor as compared to other vehicles, and heat is dissipated. So it's a very zero harmful for the environment. As I told that it's efficient power. So it can also having a good drive range, as we see the loopholes in electric vehicle that we are still facing some issues in electric vehicle that are low drive range, and the charging infrastructure issues are there. Like to cover a lot of distance, you need a too much charging infrastructure development. But somehow hydrogen vehicles, like they having a gallon of 60 to 72 liters capacities, and as per that we are going to travel up to 300 kilometers. So these shows the power, how much power efficient is that. So as I told that fuel cell vehicles, so it's very similar to electric vehicles because it's having a combination of EV powertrain plus fuel cell technology. The transmission powertrain components, like it's very similar with the EVs, like battery, controller, connections, and each of them having different function. But the power to charge, the power that you can store in the battery with the help of fuel cell stack membrane. So in that you can see that, as I started with the powertrain, because it's a very familiar, like motor. We use motor to convert from electrical energy into mechanical energy, which is used, which is connected with the transformation axle, transformer cases, gearbox to propel the wheel as per the requirement speed. Part of the body where we are going to overlap the conditions, and we are going to find the whatever the inverted power supply we are required, we are fulfilling from the DC converter. We are using DC converter to fulfill our desired level of voltage. Like we are needing some for initial or auxiliary component, we need a low voltages. It can be fulfilled by the DC converter only. Along with that, we having a thermal systems. It's similar with the battery, like in EV, BMS, BTMS is there to managing the battery as well as the cool down the system. We use thermal management system, power electronic controllers, transmissions, fuel tank, and battery pack. Is all a part of the EV powertrain. But when we're talking about fuel tank, it's a part of fuel cell technology. In the fuel cell technology, we are going to fuel cell stack. In that stack, we having a lot of cells, and each cells are going to be generate a 1 watt of power. Like some of the prototypes, we having a 370 watt, 320 watt power generations, and the R&D is still going on the fuel cell to improve their power consumption and to increase their efficient output. Like fuel filler is there, a nozzle from fuel is designed to attach the receptacle of the vehicle. Like if the nozzle is connected, we are going to fuel the battery, fuel the cylinders, and some of them now are the latest. Some of the companies are also working on the swapping of fuel cell. Like you are going to swap, like a very similar to the battery swapping system in EVs. We are going to also able to swap the fuel cell cylinders in the 4-wheeler as well as 3-wheelers. So it's very evident. So we start with how does hydrogen vehicle work. So first thing come fuel cell operation, which are going to generate the power. Second, electric drivers, like we are using controller, then motor to convert the power, to provide the power to the motor, and it can help to propel the wheel. Along with that, in all the operation, we are getting a water vapor emissions, like, or we are getting a heat also as well. So to understand that, we starting with a fuel cell. A fuel cell is a chemical energy conversion where we are using hydrogen and oxygen to produce the electricity with the electrochemical reaction, and that energy is going to be stored in the battery. The electricity which is generated with the fuel cell operation, it's not directly used by the vehicle. It is going to be stored in the battery, and we are going to be use that. Like you are going to store that battery in the battery, or somehow when the running of vehicle also the regenerative braking is there. So that power is also going to be stored on the battery, and then from the battery, as per the requirement of the motor rating, we are going to step the voltage. Like if we need a DC-DC boost converter or buck converter, we are going to require the fulfill output from that. And then we are coming with the electric drive, where it's allowed to move with a high efficiency, with a low noise. And in this whole operation, we are getting water emissions. So we start with the fuel cell. What is a fuel cell? A fuel cell is very similar to, you can say, as a battery. Like in the battery, we also having a electrolytes, anode, cathode. It's very similar to them, but somehow the raw material substances, like we are using in lithium cells, lithium ion is a main component. Like in that, we are providing hydrogen and as well as oxygens to make a electrochemical reaction, and then from we are getting an energy generated, and that energy should be stored, and it can be connected in the series connections, and we are getting a 370 volt output. 370 voltage we are getting from the full stack and a prototype of model. I will show you one of the case study as well as. So with the help of oxidation and reduction process is also there. So some of them having a chemical equations, chemical compoundation, and we are getting the energy. So is a part of one of the four-wheeler. You can see that stack cell assembly. And these stacks having a stack membrane. And that in that membrane, we having a different lot of fuel cells. And these cells are like connected in them in series, and they also having a positive electrodes and negative electrodes, and between of them we are having a membrane electrodes, and where we are getting a power supply. So I will show you one of the animation as well as for that. Okay. At an anode, separate hydrogen molecules into protons and electrons. Along with that, a proton which have a take a different part of cathodes, and we are going to regulate that. So you can see that the flow of hydrogen is from one side as anode material, as a conducting as a positive terminal, as well as cathode where it is connected as a negative terminal, and the reboundations between of them we are using that. Along with the gas diffusion layer is created between of them. The electrons go through the external circuit, creating a flow of electricity, and the protons migrate through the electrons to the cathode, where they utilize with the oxygen, and the electrons are with the help of gas diffusion systems. We are getting a positive energy, or you can see the flow of electrons between of them, and we are getting energy. That energy is going to be firstly stored in the battery, and then we are using that energy to propel the wheel or any another peripheral device, like some of them having in the name of electric vehicle transportations, we are using in the electric vehicle, you use it for a hybrid mode, but somehow it is used widely in the power stations also for a backup power supply and for the parallel scope of the market in the automations. So firstly, I can explain with the block diagram, like we start with the fuel cell. We are going to connect it with the EMS of the energy management system, where it's a complete energy management system from single dotted line. You can say as a unidirectional, where and the dotted symbols indicate about the unidirectional symbols. Along with that, we are having a deep side where the electrical energy is transmitted, and the more bold sign symbols about the mechanical transmission in the vehicle. So we're starting with the fuel cell. How the fuel cell will be stoked, it's be filled by the outer of vehicle with the like charging infrastructure is having a hydrogen stations. Along with that, you are getting a power from, you are giving power with the after the electrochemical reaction, it's going to store the power in the battery with the help of DC-DC converter. We having a buck boost converter here, and we are going to store the battery, as well as the regenerative braking connections are there also with the motor. So at that time also power is going to be stored on the battery, and when we are needed to run the vehicles, the battery is going to draw on the power which is used to control, and with the help of motor we are going to propel the gear with the differential. We are having in the differential from then it's going to propel the wheel. So these how the power is going to be transmitted from the fuel cell to the EV body. So I will show you one of the video also, like its video will give a complete explanation. This video is one of the fuel cell of it's announced by the Toyota in the 2015 Toyota Mirai, and these give a clear explanation about how the cell membrane is working and how much efficient is giving the power. So you can see that the power electronic components, powertrain components, as well as the fuel cell technologies, same video. So we are providing the oxygen, hydrogen with the air passes, and from the hydrogen is having, it can be refilled by the charging stations. So we also have to work on the charging infrastructure, like similar for the EVs, we have to work on the hydrogen, but we have to need more safety precautions while with the hydrogen substations. So you can see that the power should be delivered with the uphilling or down phase, like the power required a high load driving or low load driving. It can be circulated and suitable for that with the low noise configurations. And these are the major components in the fuel cell. It's also a part, you can say, as a hybrid part of electric vehicle. At the time of energy recovering, is there also to, but in nowadays energy recovering is not directly is there. We are having a regenerative braking system while working with the smooth configurations. But the fuel cell membranes, you can see that a lot of membranes are there. It's having a 370 cells in this particular module. Due to the positive and negative electrolytes, we are going to that the flow of electrons from one side to another side, we are getting a power, and that electricity should be stored in the batteries, and it should be required. It should be as per the desired rate. We are convert with the PI controllers, power electronic converters, and we use that power for to similar. So let's start with talking about advantages. The advantages of hydrogen vehicles. One of the most compelling aspects of their ability to producing zero emissions. So it's a very, of course, just like a lot of vehicles having like in electric vehicle only, as take example, we having in the hybrid mode, it's very highly costly as per the, some of them are having emission as well as. But in this hybrid model also, or a fuel cell particular model also, you can't see any of the emissions. Hydrogen vehicles offer a cleaner and more sustainable solutions. The boost energy, efficiency, excellent performance, and the quick of refueling. Like we are not giving a lot of time value to charge the vehicle. Like one of the major drawbacks we find in the EV, like, or we can say as a loophole of EV, that we are facing too much time while in the charging of vehicle. But in the hydrogen, it's very evident. A quick refueling is take a little bit of 5 minutes to refuel your vehicle. So reduce the depends on the fossil fuels. So quick refueling, zero emissions is a major advantages we are seeing in the hydrogen vehicles. But still, while the potential benefits are clear, it's important to acknowledge the challenges and concerns the surrounding of hydrogen vehicles. Like we have to more focusing on their like highly productive cost, limited refueling infrastructure. Like it's a very too much reason why we are not using hydrogen as like similar with the EVs. Like we are seeing a lot of like Nexon EV Nexon EV Punch, which are launched by the Tata, Mahindras. But why we are not promoting that much in the hydrogen? Because of the manufacturing cost. But somehow in upcoming days, we are also seeing some of the prototype, and with the high efficient power is similar with the a more efficient and more suitable as compared to EV. It's going to be coming in the market in upcoming years. And some of the MNC companies and some of the automation industries company, which is more honorable and honestable by the customers like Tata, Mahindra, they are working on the hydrogen power plant setup also as a back end to promote their vehicle, and they are going to be a great revolution should be there on them. So safety concerns is very much more higher in the hydrogen vehicles because we are setting a power with for a hydrogen setup, and in the same charging stations or maybe we have to plant in separate infrastructure. So we have to basically safety concerns is a key factor that we are going to address when we are moving towards the hydrogen vehicle. So as per my convenience, we are having a lot of drawbacks, loopholes in everything, like disadvantages and advantages. But safety concern is a more evident part of which we are facing with the hydrogen electric vehicle. Like we are using with the infrastructure development, then also we have to safety is there. Well, when we are going for a cost reduction for a more suitable, then also we are have to looking on the safety of customer who are going to be sit on the fuel cell vehicle. But some of them are having legacy of no noise, high efficient power with the pocket friendly. So some of them are the vehicles are going to be designed as per in upcoming years. So the current state of hydrogen vehicles in the market, like technology advancement, collaborations, investments, global market penetrations. So the recent technology advance addressing many of these challenges. As I told that these challenges, which are the drawbacks of hydrogen vehicles, should be rectified by the upcoming years, breakthrough the hydrogen fuel cell technology and leading to improve their efficiencies and the cost reduction as well. So the research and the making and spreading of materials our manufacturing process bring closer for more suitable and economical valuable for the customer, as well as government supportable is also there. A huge government supportable is there, and in India as well as many of the companies in the European market is launched very well. And as a several manufacturer embrace a hydrogen technology model like Toyota, Hyundai, and nowadays Honda is also going to be work on that. Like in the year of 2013, Honda is going to launch a fuel cell vehicles. Toyota, one of the success, Mirai, 2015 was in the 2050 it launched, and the Honda is enter in the market of fuel cell technology in the European market. So these are the global, as per the, also we are providing a subsidies by the help of government while when you are manufacturing the eco-friendly vehicle and more suitable for users. So you can see a lot of efficient or startups are there, and the company investors are there for the green mobility. Okay. So I'm going to discuss about one of the case study of hydrogen vehicle and what are the spare parts, what are the powertrain and their rating should be there in that particular vehicles. As I mentioned that Toyota and Hyundai is one of the major company, it's in the 2015-13, they has launched their vehicles and they are promoted, and they are more performing in the hydrogen vehicles, sustainable transportations, and positive impact in the automation field also. So I will show you one of them. What are the parameters of them? What are the hydrogen tank? Which type of motor is there be using? And what are the efficiency? Which type of battery? Somehow previously in many of the fuel cell technologies there, and to store the charge we are preferring NMC cells. To store the charge, we are preferring NMC cells for the energy management and the regenerative braking systems with the 370, 320 cells connections are there. But now it's are more preferable with the lithium ion batteries also, with the safety also. So in this vehicle, we are preferring the lithium ion battery, which we are getting a voltage of 310 voltages, and the battery current rating ampere should be 4 ampere hour, and the kilowatt should be 1.24 kilowatt. Motor type should be a permanent magnet synchronous motor. So we need a controller with having a resolver connected with it, so we can easily to propel the shaft. And electric motor should be a part of 1.3 kilowatt. But as compared to that power, in electric vehicles, like 30.6 kilowatt hour energy is there. So as compared to this, the power is very less in the fuel cell technology, but we are getting a driving range very high as compared to that. Like with the motor torque, peak torque should be as a 3 Newton meter per second. The mileage estimation should be at the tank of 71 and 72 liter, we are going to cover 647 kilometer, but in on-road price, it's cover only up to 350, 360. But in the highly with the plain slope and the ideal condition, we are able to get a 647 kilometer, as well as the Toyota fuel cell systems having a 128 kilowatt power. Number of cells are 330. In some of them, like Honda is going to be for a 380 numbers of cells. Hydrogen tanks for to refueling it will take 5 minutes, and number of tanks should be 3. But in different model you can find these parameters, but the specification should be different. Like it will take 3 tank, it will take 2 tank, and many of them the parameters should be more efficiently. Like we are getting the power, and the life cycle of the battery should be also there. Like how much time should be the battery we are selecting for that, the life cycle, we can improve the life cycle of the battery also. And nowadays, some of the major things like another crude fuels are also there. Like in the companies are also working on that, like ethanol, some of the acetate foam of the sugar cane. So the juice that we are getting from the sugar cane, that the crude pulp is also used for an algae systems which are using for the in upcoming year for the fueling material in the vehicles. So these are type of R&D and innovations are going on the hydrogen fuel cell, as well as simultaneously others also. So we know only that hydrogen fuel cell is a part of, like, for a bus, for truck, in some of the trucks for the prototype model we have seen, but somehow in some of the houses in the European market, as well as some of the researching part, and NHPC is also using hydrogen power. Like hydrogen powers are used for, like, for the we are getting the power with the where the transmission part should or be not there, or in the power plant or nuclear power plant also it is used for a backup power supply. So these are the applications where we find the fuel cell. Along with that, these are the type of the future of hydrogen vehicles and their role of sustainable futures. So how the vehicle is going to be, like, we already have a diesel petrol vehicles, but why people are going to be switch on the hydrogen vehicle? There is a major cost, like, because the cost is also high. But in upcoming year, we are going to see like that the cost should be very much reducted, because always the new market scope, the price should be high at that particular time. But some of the interval of time, you can see that the lot of the production and lot of competitors are there. So the reduction of cost, we are going to see that, and it's create a huge parallel scope with the IC conventional engine, electric vehicle engine, or the hydrogen fuel based vehicles. So which is more helpful with the market adaptation and the sustainabilities, along with the government incentives are given by while the manufacturing of the vehicle and while the purchasing of the vehicle, while in the tax reduction. or while in the ground clearance at the time of registering of your vehicles also, you are getting a more like cost reduction should be also there in the hydrogen vehicles as well as. So we will find that as suitable mobility, integration of the renewable energy, marketing expansion, hydrogen fuel cells are used. So we are getting a more efficiently and adapted part in the automation industries as well as renewable energies also. So with the help of that, you are going to run the turbine, you are generate the power when we're talking about like MEG systems, like a small part of energy generation or for a backup renewable energy sources, we are using hydrogen as well as. Okay. So as a future outlook, when we are looking towards the future, hydrogen vehicles present a significant steps towards the sustainable futures as we navigate the challenges and the capacity on the technology breakthrough, the potential benefits and the emissions. But when we are talking about the government incentives, the government is going to promote that, and so the potential growth of hydrogen vehicle market is anticipated the technology advancement. So whatever the advantages we are going see, it's by the help of the investments along with the government help, and the global investments are there to widely spread the adoptions and promises of the technology with the low emissions, low or zero emissions. So that's why we are moving toward the e-mobility and more sustainable products. Okay, so when we are talking about like in India and the government, like NHM, National Hydrogen Mission is there. So what was the role of National Hydrogen Mission as a drawn up to a roadmap for using a hydrogen for energy source, and the key focusing on generation from green power resources, and it can also be a mode of exchange from upcoming years for the neighbor countries to link the India with a growing renewable capacity with the hydrogen economy. So it can boost the economic also. Along with that, Indian ambitions of global of 175 gigawatt power. That 175 gigawatt power should be generated, and that can be fulfilled by the area. Like we are having renewable and non-renewable power supplies. So we are using not only for the backup, but we are also used for the always for the requirement of the basic necessity of the electricity. And it is being budgeted by the 2022 by the Indian government. In 2022, it's allocated a 1,500 crore for the renewable energy sources plant. And these uses hydrogen will be not helpful for the India to achieve the emission goals under the Paris Agreement, but also it will import the dependency of the fossil fuels. Like we are getting a fossil fuels from some other country with the mean of exchange, we are also use the hydrogen to fulfill their requirement, or we can use as a better system as well. Okay, so as I told that we are looking for a more government incentive subsidies which are promoting the hydrogen vehicles. Along with that, we are also we need to work on the charging infrastructure, which is rebounded with the companies of automation fields like Tata, Mahindra, a huge country. Huge part of that, like some of them are still working, and Tata is also going to be somehow insightful knowledge that they are going to be establish a power plant on the hydrogen basis. And as I told that we are talking about India government, Honorable Transport Minister Nitin Gadkari is a major looking for the innovation and more sustainable transportation. So our transportation minister will help and promote always as an electric vehicle and hydrogen vehicles. So in upcoming year, of course, you are going to see in your roadways about running of the hydrogen vehicles. And somehow it is more familiar with the Indian plan, like the Indian roadways. So we have to design and we have to innovate it as per the requirement. But as like EV is booming, So it's a part of hybrid mode. We are saying like a fuel cell and hydrogen part. But somehow, along with the EV also, we are having a parallel scope of hydrogen market. So as a IC conventional vehicle is there, hydrogen vehicle is there, and EVs are also there. But in most of them, you can see that the low emissions, zero emissions, they are in the hydrogen vehicle only. Because we don't have to any charging, discharging, and we are not having like a low drive range in this vehicle. Because we are, as compared to EVs, we find a lot driving range in them. But somehow, like fuel cell, in the fuel cell having also 4, 5 types like solid, alkaline, and phosphoric acids, and PME. So these are different types of fuel cell, and these all cells having different chemistries and their efficient parameters. So as per the rating, as per the selection, we are have to pay the cost, and as well as the cost reduction should be there also from the innovative team. So we will see that fuel cell will going to be major and good scope in upcoming year in the market. So this is from my side. Now I would like to open the floor for any questions regarding the hydrogen vehicles. Like I'm not covering all the topics of hydrogen with the chemical equations. If we are going, it's very like evident for chemical reaction should be there with the help of electrolysis process, and that charge is going to be stored in the battery, and then from the battery we are going to propel the vehicle for four-wheeler, for like for the truck, for the fuel cell buses. We are going to see all that things in upcoming years. So that's from my side. So if you have any questions regarding that, you can ask.
Sir, I have a question.
Yeah.
Sir, what is the main challenge with hydrogen fuel cell systems?
Basically, the main challenge is where we are talking about like safety is also there because of the cylindricals, and as well as the when we are see in the EVs as well as like infrastructure development. So the main challenging, I said, like a infrastructure development, and as well as the cost is very high.
Okay, sir. So another question is, what metals are used in hydrogen fuel system?
What metals? Like we are having like cell membrane, like in the in batteries, like graphite, cathode anodes are there, but in the fuel cell, like alkaline materials are there. In the fuel cell, alkaline materials are there, and they are also different types like PME, phosphorus, and there are several factors. As per that, we are selecting that particular materials.
Okay, sir. Thank you.
Okay.
Sir, apart from the PEM fuel cells, do we have any other type of fuel cells which are advantageous like SOFC? So why is it that most of the time PEM is being talked about in the fuel cells?
Basically, because of the high efficient we are getting from the PME fuel cells. But when we are talking about the solid state, okay, when we're talking about the solid state of fuel cell or alkaline fuel cell, we have to like change some of the chemistry composition on that, and then also the power density should be similar to that, and we can also use for in upcoming vehicles. But somehow the cost of the manufacturing value, the chemistry changing of that particular component is high, which also impact the cost of vehicle also. That's why PEM fuel cells are more suitable, or you can see in the major of prototype of upcoming, like from Mahindra, Hyundai, and Hondas are also going to launch the vehicles in for the prototype. We can see the PEM fuel cell only.
One more advantage is there. They are working on at low temperatures, so startup time is also less in fuel cell.
Yes.
And so one more thing. So is there any specific method that is used to store this? So like I've heard about this pressurized tank storage method. So
Pressurized tank storage method is there, and along with that, The power like hydrogen we are storing there, now it will deliver that power in the pressure to the stack membrane. Okay. And from the stack membrane, the whatever the electricity should be generated, and that electricity should be again stored in the battery. And from their battery, we are going to propel the power. Okay. So the basically the pressure tanks are used to like whatever the delivery for the stack cell membrane, which is fulfilled by the pressurized form only.
Okay, sir.
Sir, is the battery parameter is the must, or is there any technology develop or developing that directly this hydrogen fuel is used to drive the vehicle?
Basically directly like you can say like as a super capacitor now. It's very like super capacitors, we can charge the capacitor and we can discharge that. But somehow we are in the fuel cell technology or fuel cell membrane, we are due the help of chemical reaction of hydrogen and oxygen, we are generating electricity on it. But we can't store that energy from there to directly propel the wheel. So we need some of the components like we need battery where we are going to store the charge and then we are going to deliver the power for the requirement. If we like in upcoming, like we can directly provide with the fuel cell, like when we are talking about high peak power, so it can be fulfilled by like you can delivering the power direct to the motor or a high traction motor, as we are getting a backside power supply from the battery as well as. Okay. So now it's not like we never giving direct power supply to the traction motor with the directly with the fuel cell. It firstly goes to the battery only, then it's showing deliver the power. Okay.
So it means, sir, that hydrogen will work as a power source for the vehicle.
Yes.
So that energy will be converted to the battery. Battery will store, and whenever required to the vehicle, it will be converted from battery.
It's very similar to conventional vehicle. Like we are refilling the petrol, diesel. So in this vehicle, we have to refill the hydrogen. Okay. Like hydrogen, we have to refill the hydrogen as per the liters, and it will, as per the liter we are getting, as per the storage tank is there in the vehicle, we are use that. Like it's very similar to IC conventional vehicle where we are going to fill the petrol, diesels, we are going to fill the hydrogen on it. When we are talking about electric vehicle, we are charging the batteries. Like instead of refueling, we are charging the batteries for 2 hours, 3 hours, and DC fast charger, it will take 1 hour. So it's similar to that only. Like we have to provide a hydrogen from outside. That's why the infrastructures part come on the role. Like we need also to set up a charging stations. As similar to EV charging station, we are also have to set up a hydrogen charging stations.
So we know that hydrogen is very reactive, right? So
yeah, it's very
common. Yeah, so it can cause fire or damage. It can be dangerous. So so now so liquid hydrogen is dangerous, I think. So when we use
liquid
it,
hydrogen is a more dangerous.
Yeah. So when we now use in the form of fuel cells, right? So what is it about fuel cells, or is there any harm or danger similar to liquid hydrogen, or it is way more safer or like that?
No, like liquid hydrogen is more dangerous. As we told that, like we are using in the fuel cell, so we are like in as I mentioned that we are using like battery. So in the battery, cathode, anode are there. We are using NMC cells, nickel cadmium material, lithium material, sodium materials in the battery. So instead of that, we are providing a hydrogen, and we are using that for the generating the power. Okay. And as your questions about like is more safer or not, to make more safer also we have to improve the insulation part of the hydrogen tank, because a person is going to be sit on the vehicle. So somehow we have to more concern about the safety in the vehicle. So the liquid hydrogen is more dangerous. So it's form in the fuel cell is coming on the form of solid state also. So that's why some of the compositions, and we are using the fuel cell with the solid state also, in the solid state only, with the for the safety concern of the human only.
So when this is used in the form of solid, so then again does the storage comes into the point, because I think it requires more
because
storage.
in the solid state now, in the solid state, basically one of the Japanese companies is launched. In the solid state, they are using a swapping battery system on that. Like a battery, you are swap the cylinders. Okay.
Sir, may I answer this question?
Hello. Yeah.
Hello.
You can. Yes, you can answer this, sir.
Sir, in case of solid oxide, they are using porous activated carbon materials. So what is there? They are arresting the hydronium ions, H positive, and later on when they are reversing the connections, so the fuel cell moves into the electrolyzer mode. And as a result, the weak van der Waals forces break up and they continue to work as an electrolyzer. So then it becomes a two-way process. So then we can go away with the battery pack, because the charging and discharging process will be working as a single unit only. But
Yes.
we need a small battery pack to provide the instantaneous reversal of power, because fuel cell doesn't provide instantaneous reversal of power. So that's why we have to use a battery pack, but that is of very small capacity.
Okay. So directly we can is a bi-directional part.
Yeah, bidirectional.
Okay.
Hello?
It's a good point. You can add that. Yes, sir. Yes.
Yeah, hi. Talking about the green hydrogen, can you please tell me the overall efficiency of using the green hydrogen? Means the electricity used to extract the clean hydrogen and electricity removed from that hydrogen to drive the vehicle. Can you please tell me on screen with some figures or
In some figures.
overall something, some randoms?
No, but now in this PPT, I included only about the basics of hydrogen and what are the fuel cell, how it's working. And I added one of the case study in that. In the pictures, in the PPTs, I don't have that efficiency chart.
Very cool. But can you please tell me, is it efficient or how much it is efficient? In percentage something. Yeah. How much percent of electricity is converted to hydrogen, and from how much percent we get it back as a power source for vehicle?
Efficiently, like
He is talking about round the trip efficiency.
round tap efficiencies, but
Round the trip efficiency he is talking about.
like efficiency, I'm not getting it. I'm exactly the value I don't have. Like I don't have exact in the percentages.
Mm-hmm. So some lump sum you can say to have a study in this field. So
Yeah, it's
okay.
about
Okay,
like
it's fine.
68 to 69%. I'm not getting exact value, but it's 68 to 69%.
Okay, so that's cool. And
Okay.
yeah, that's fine. Hello.
Yes.
Hello. And sorry, I have joined late. I don't know about your organization or your company. So how does SDC works, or what it is actually?
SDC.
No, not SDC, something. What is the organization? I'm sorry.
Okay. Basically, our organization is ISI India, Imperial Society of Innovative Engineering, and we are providing trainings. We are organized the courses. We are running courses. We are also delivering the knowledge, and we are also working on the majorly working on the EV sectors.
Okay.
And like you can enhance your skills, so we are providing also the software knowledge. At 5 minutes, I will show you one of the promotion video as well, as so you can get a better understanding about our organization. And somehow, like, we are also going to organize some of the events which are based on the electric vehicles, So what are the parameters, formulas of the EV vehicles? Okay.
Okay, sure. Thank you.
Okay. So I think I don't have any more questions. So I'm going to wrap the session from my side. So please, concerned team, uh, take the session from here.
Yeah, sure. Thanks, Jesh, for hosting the webinar. Your expertise and insights were invaluable for our learners. And I would like to take the opportunity to introduce our company, ISIE India, products and services that we offer in AV technology with small video. So have a patience and look further with the small video.
Hello, engineers. Do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISI India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV CAD and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSGC and ASGC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSGC Government of India. Along with the courses for skilling, reskilling, and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation, and product design and development. It is a combination of 6 labs, including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab, and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, two-wheeler, three-wheeler, four-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off-grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions, and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Thanks, learners, for watching the video patiently. So don't miss out the opportunities to discover the endless possibilities of electric vehicle. So any of you want to enroll in the course, kindly send us inquiry through a QR code that will be displayed on your screen and take your first step towards a more sustainable and exciting future.
विकास एक इंची के 3 और है मेरे पास वो जैसा कि तो लाओ मैं एडिट कर देता हूँ तो पहले भेजो मेरे को बढ़ता है पूरा प्रोसेस
Okay, are you looking for a job internship in the digital marketing? Sorry, an extension.
Hello.
Yeah, I need for the internship.
Hello.
Yeah, are you comfortable with anything?
Hello, excuse me. Hello, ma'am. Ma'am, are we required to fill in some details in the feedback link to generate the certificate or not? Okay, that will be provided in the email only. Thank you so much, ma'am. So can we leave? Okay. Okay. Thank you. No worries. Thank you.
Hello, excuse me.
Yes.
Sir, if I train in ISIA India, what is the process?
You can scan the code and you can connect with the team. So
Okay, sir.
he or she will help you in that courses and whatever your requirement regarding courses. Okay.